Assalamualaikum. We are from Group 7. So today we are going to show a video live presentation about low impact development.
Assalamualaikum, I Muhammad Rozi Jahya will explain background information about low impact development (LID). It is more than two-thirds of the world population are projected to live in urban areas, and most of this urban growth will take place in lower and lower middle income countries. But decently built up urban space tend to come with challenges of their own. Therefore, there is need to start ensuring today that this urban area will be inclusive, safe, sustainable, and resilient. In urban and suburban areas, much of the land surface is covered by building and pavement, which do not allow rain to soak into the ground. Instead, most developed areas rely on storm drain to carry large amount of runoff from roof and paved area to nearby waterway. The stormwater runoff carries pollution such as oil, dirt, chemical, and lawn fertilizer directly to streams and rivers, where they seriously harm water quality. One best way to protect surface water quality and groundwater resources is by implementing low-impact development. The term low-impact development (LID) refers to systems that variety of practice that use mimic natural process that result in infiltration, evaporation, or use stormwater in order to protect water quality and associated aquatic habitat. LID include a variety of practice that mimic or perceive natural drainage process to manage stormwater. LID practice typically return rainwater and encourage it to soak into the ground rather than allowing it to run off into ditches and storm drain where it would otherwise contribute to flooding and pollution problems.
By creating impervious surface, rapid urbanization reduce natural watershed storage, increase drainage density. The changing impervious surface balance has a significant impact on both quality and quantity of stormwater runoff on both, according to Bannerman in 1993. As a result, this will cause a water pollutant. Many governments around the world, including Malaysia, have invested millions of dollars to combat the problem of frequent flooding. Engineers have traditionally used structural measures like conveyance and detention ponds to deal with stormwater issues, as well as larger, deeper drains to accommodate increased water capacity. For decades, stormwater management systems have relied primarily on collection and conveyance systems for the removal of water from developed areas in order to protect life and property. Conventional flood control methods, on the other hand, raise the question of whether or not these methods are effective, environmentally friendly, and cost-effective in the long run. In other short term, is sustainable. Furthermore, uh, the witness in current system cause river flow velocity to rise and bank erosion to accelerate, which cause river to become shallower because of precipitation eroded materials that have accumulated on bank. As a result, compared to rural or undeveloped areas, urban areas present more challenging features in order to effectively manage stormwater. The built environment necessitates a holistic approach that takes into account all of the various factors involved. A fundamental tenet of low-impact development is to manage rainfall at its source using uniformly distributed, decentralized micro-scale control, much like nature does. Site planning, land development, and stormwater management are all brought together as part of new development strategy aimed at preserving the ecosystem. This study is attempting to evaluate the effectiveness of low impact development in post-development residential area or urban area, realizing the importance of controlling stormwater runoff in urban areas, which it will cause water pollutant to our water resources and produce uh, uh, bad water quality for our future. So that's all from introduction. We can continue through the literature review.
Site design strategy. Low is aimed at preserving or recreating pre-development hydrologic condition by employing design techniques to create a functionally equivalent hydrologic landscape. Techniques like this one have been developed to allow for the retention, storage, and infiltration of water runoff generated by urbanization, microscale stormwater retention, and detention area that are integrated and distributed across the landscape, as well as the reduction of impervious surface, help to maintain water storage, infiltration, and groundwater recharge. According to Kaufman in 2000, Prince George County, Maryland, pioneered low-impact development method in the early 1990, and the state has since implemented several projects using them. Both the economy and the environment benefit from the use of low-impact development techniques. Traditional stormwater management methods are more disruptive to the natural environment and more expensive than low-impact development methods. Non-structural and non-structural and structural approach approaches approaches to low impact development are the two main types: protecting sensitive area, minimizing soil compaction and impervious area, and disconnecting stormwater source are all examples of non-structural approaches commonly used in pre-development. In the meantime, damage to the post-development area is being repaired structurally. Bioretention, certain walls, and permeable paving are all examples of structural low-impact development. Method. This study will be conducted using a small-scale experiment in the chosen location. This research employs a structural approach known as low-impact development. Bioretention and systems were selected for the simulation process because of their low environment impact. Both features were modeled modeled in software and hypothetically retrofitted in the residential area in Kuala Lumpur, Taman Wangsa Melawati. There were 9 small catchment areas for easy monitoring of low-impact development in the study area. On the basis of Maryland guideline issued in 1999, the area of the bioretention was calculated at 5 to 7% of the drainage area. This was done in accordance with Prince George County guidelines. On the other hand, MSMA's Swinburne method was used to calculate the volume of the cistern, which is a RWSHS device, in order to ensure that this simulation was carried out correctly. NACE provided use which the actual storage capacity of the cistern in 2008. That how long it's long, how wide it's wide, and how deep it's deep. According to his study, as a result, 10 houses are retrofit in every catchment. XPSWMM was used to design the hydrological model for this study, which include all the necessary parameters. For the purpose of the real world location, this type of design was chosen. There was no way around it. Site confirmation was a requirement in addition to performing calculation to determine the dimension of the two components of low impact development.
As a result and analysis, the the effectiveness of retrofitting with low impact development features like cistern and bioretention was examined. The peak flow and total runoff volume of these two features were compared to determine the effectiveness of low impact development retrofitting. In the catchments where low impact development has been implemented, the nodes show how much runoff has been reduced. The result of each analysis were compared to those of a conventional scenario that had not been modified to include low impact development elements. Cisterns are designed to hold water before it is released into the drainage system, which is why they are installed. Because it collects the water, it reduces its peak flow and runoff volume, thereby reducing its environmental impact. Both infiltration and retention storage can be performed by bioretention, which has two primary functions. A natural and man-made stormwater management system is used in the development areas. Additionally, it aids in the restoration of flow pattern to their pre-development state. There used to be a widespread belief that bioretention had little effect and controlling water quantity and provide only modest flood volume reduction in every catchment. Moreover, had in 2009 accepted that reducing the P is critical for stormwater management in existing areas that are undergoing urban densification, where higher flow are a major stressor. Impervious surface percentage had an impact on both low impact development (RWHS) and low impact development bioretention result. While impervious surface was set to 100% in the low impact development RWHS simulation, the percentage was reduced to 70% in all catchment for the low impact development bioretention system, which filters divert runoff through dense vegetation and then vertically through soil filter media. Water has more chance to seep into the soil when there is less impervious surface area. Low impact development (LID) is a technique that encourages more infiltration, and infiltration is an important part of LID implementation. Kisken are designed to hold water before it is released into the drainage system, which is why they are installed, because it collects the water. It reduces its peak flow and runoff volume, thereby reducing its environmental impact. Both infiltration and retention storage can be performed by bioretention, which has two primary functions: a natural and man-made stormwater management system is used in the development area. Additionally, it aids in the restoration of flow pattern to their pre-development state, as opposed to popular belief which had that bioretention had limited potential for reducing water volume and providing only a marginal level of flood protection. As a conclusion, simulated rainfall and runoff from 9 resident catchments that had low impact development features retrofitted into them are presented in this study. The findings suggest that some low impact development features may be able to reduce the volume and peak flow of runoff. Conclusion: the effectiveness of low impact development retrofitting can be assessed using these two variables: runoff volume and peak flow. There are significant implications for urban stormwater management based on the simulation result. It implies that a more environmentally friendly stormwater management system can be retrofitted using low impact development technique. Instead of collecting runoff in pipe and channelized network and controlling the flow downstream in large stormwater management facilities, this approach aims to preserve the pre-development hydrology system and water quality by managing runoff closer to where it originates. Thank you from Group 7, and perhaps everyone understand what we are talking about. Thank you.